Hola, Mr. Sutton here, bringing you this Pre-Cal Honors 9-5 Part 2 homework solutions on limits at infinity. For this problem, we're trying to find the limit as x approaches infinity of x cubed over e to the 3x. Now, the key on this one is recognizing that an exponential function grows faster as you move towards infinity than a polynomial does. So that means this is a bottom-heavy function, which means if the denominator is growing faster and faster than the numerator, eventually this thing is shrinking down to 0. So y equals 0 is our horizontal asymptote, or just what this thing becomes, giving us an answer of choice A. For this problem, we're trying to find the limit as x approaches negative infinity of this fraction with these exponential functions in it. Now, one thing you have to be really careful about with exponential functions, they have different left and right long-term behavior. As you move to the right on an exponential function, you're going to positive infinity, but as you move toward the left, you've got that horizontal asymptote at y equals 0. So that's what we're doing here. We're moving to the left. So one way you could think about this is, as you move to the left on these are both becoming 0. Or another way you could do this, if you want to be a little more algebraic about it, you could make this a positive infinity, but then make these negative x's in the actual limit here. And if you look at it this way, we've really got 3 plus 1 over 2 to the x and 4 minus 1 over 5 to the x. And we know that if x is approaching infinity, you've essentially got 1 over infinity, 1 over infinity. Those are both becoming 0. So you've got 3 plus 0 over 4 minus 0, or just simply 3/4. Choice C. For this problem, we have a function given by this crazy expression with a's and b's in it. And we're given a figure above that shows just a portion of this function. And we've got a horizontal asymptote at 3 and a vertical asymptote at 2. Based off of this, we want to know the values of these constants a and b. So the key here is we have to use those asymptotes in a variety of ways to get these missing constants. So to get a, what I'm going to do here is I'm going to use this horizontal asymptote. Since I have a horizontal asymptote at 3, that means that the limit as x approaches at the very least positive infinity of this thing has to equal 3. So I'm going to set it up like this. Limit as x approaches infinity of all this stuff equals 3. And now since I'm going to infinity on this limit, I can ignore these slower growing terms, such as 12 and the constant b. So I can write limit of ax squared over x squared equals 3. Limit as x approaches infinity. Now I can cancel out those x's, leaving me with just a equals 3. All right, so that at least narrows it down to answer choices D and E. Now we have to figure out this b value. The key here is recognizing that we have this vertical asymptote at x equals 2. That means that if I plug 2 in for this x down here in the x squared and add it with b, it should all come out to 0. Because the only way you get a vertical asymptote is if your denominator is 0. So I'm going to set it up as so here. X squared plus b equals 0. I know that x is 2 when all of this comes out to 0. So I just have 2 squared plus b equals 0. Well, that's just 4 plus b equals 0. So subtracting 4 from both sides, we get b equals negative 4. So we had a was 3, b was negative 4. That leaves us with answer choice D. On this problem, if k is a positive integer, then they want to know the limit as x approaches positive infinity of x to the k over e to the x. So the situation we have here, since k is just a constant really, we have a power function over an exponential function. Now, this by itself doesn't tell us what the infinite limit's going to be, but since we are going to positive infinity, that means the exponential function is also going to infinity rather than 0. It would be 0 if we were doing negative infinity for that exponential function. Exponential outgrows power function as you go to infinity. The exponential function is faster. So that means our denominator is growing faster. We have a bottom-heavy function, which means that this limit is just going to shrink to 0 as we go to infinity. So that ends up giving us answer choice A. For this problem, we have the function y equals 5 plus 2 to the x over 1 minus 2 to the x. We want to know all the horizontal asymptotes of this graph. Now, since they said all the horizontal asymptotes, that should at least be raising some red flags that we might get more than one. To get the horizontal asymptotes of any function, you have to consider the limits as x approaches positive infinity and negative infinity. Let's do negative infinity first for this thing. So considering the limit as x approaches negative infinity for this, if you were to plug in negative infinity here, you would end up with 5 plus 2 over infinity, or actually 1 over 2 to the infinity, and then over 1 minus 1 over 2 to the infinity, like so. So basically you have this negative infinite exponent that brings you down to the denominator for both of those. Well, this is essentially 1 over infinity, which is 0, so 5 plus 0 on the top. This is, again, 1 over infinity, which is just 0, so we have just 1 on the bottom, or 1 minus 0. So if we have 5 plus 0 over 1 minus 0, that ends up being just 5. Now, another way you could think about this, if this doesn't quite resonate with you, as we go to the far left, which is what negative infinity means, on one of these exponential functions, remember what these exponential functions look like. 2 to the x looks like this, right? You're doing this sort of thing. But if you're going up and forever to the right, on these exponentials, you're actually approaching the x-axis with that horizontal asymptote at y equals 0 as you move to the left. So just another reason these 2 to the x's become zeros when you plug in negative infinity. So that's one asymptote, y equals 5, and that's one of the answer choices, 2 of them actually. So let's consider as x approaches positive infinity now. So as x approaches positive infinity, these 2 to the x's are the dominant terms, the champions on each side. So we can just forget about the 1 and the 5 here, leaving us with just 2 to the x over negative 2 to the x. And if we just have something over negative version of that something, well, that just reduces to negative 1. So 5 and negative 1 were both horizontal asymptotes, giving us answer choice E. For number 6, if the graph of y equals this fraction has a horizontal asymptote at y equals 2 and a vertical asymptote at x equals negative 3, what is a plus c? And we have to find out a and c based on this information. So let's start with the horizontal asymptote. When they say we have a horizontal asymptote at 2, we're essentially saying that the limit as x approaches infinity of this stuff equals 2. And also possibly x approaching negative infinity. We'll try infinity first, though, and see what happens. So here we're picking our champion. On the top we've got just ax. That's a linear term growing faster than a constant. On the bottom we just have x. So x is canceling, just leaves us with a equals 2. Next we have to figure out the vertical asymptote piece of this. If this has a vertical asymptote at negative 3, that means that negative 3 plus the c in this denominator has got to come out to 0, which means that c has to be positive 3. Now careful, we don't want to just conclude that this is the answer, right? They wanted a plus c. I'm actually surprised they didn't include 2 or 3 as any of the answer choices. But at the end we have to add 2 and 3 together. Don't mess it up now, right? So that comes out to 5, choice E. For this problem, if a and b are positive constants, then what is the limit as x approaches infinity of this weird, rational, logarithmic, hybrid sort of thing? All right, x is growing to infinity. That means that at least within here, we can ignore these slower growing terms of 1 and 3. So this is really just ln of bx over ln of ax squared. And if you're not really sure where to proceed from here, a little trick we can use is some of our logarithmic rules. We know that when we're taking the log of a product, we can split that up into log of, or ln of b plus ln of x in the numerator, and ln of a plus ln of x squared, or 2 ln of x, if you want to call it that, in the denominator, because we can pop out that exponent in front of the ln. So this is just using our log rules to split this up. And now, as x approaches infinity, we can ignore these slower growing terms of ln of b and ln of a, because those are constants, versus these terms here that have variables. So really we're just looking at ln of x over 2 ln of x. And the ln of x's can cancel, leaving us with just 1/2, which is answer choice B. For 12, we've got this rational function. We want to know where the horizontal asymptote is for this. So basically we need to find the limit as this thing approaches infinity or negative infinity. It won't matter for these. Now we want to make sure we actually have this at least kind of multiplied out before we do the whole choose your champion thing. Up top, the biggest term is going to be the 3x times the negative 4x, or negative 12x squared. On the bottom, we've got 2x times itself if we write this twice and multiply it out. So 4x squared on the bottom. So ignoring all the other terms and just looking at those two fastest growing terms, we can reduce this to negative 3, which gives us our horizontal asymptote, and that's going to be choice B. For number 9, we're given the function e to the x, and we want to know which line is an asymptote to that graph. Now this is one where if you know your function families, you remember that exponential functions like e to the x have asymptotes at y equals 0. They can't be 0 or negative. But if you forgot that, we could do it the calculus way, which is to take the limit as x approaches infinity and negative infinity of this function. Let's do negative infinity first. So if we plug in negative infinity, e to the negative infinity, we can rewrite that as 1 over e to the positive infinity. And then that's really 1 over infinity, which is 0, constant over infinity. Now, this suggests that we do in fact have a horizontal asymptote at y equals 0, but just to be sure, let's plug in positive infinity as well to make sure there's nothing weird going on at the right. E to the infinity is just infinity, so we just have y equals 0 as the only horizontal asymptote moving to the left, choice A. For number 10, we want to know for which of the following does the limit as x approaches infinity equal 0. So we have a whole bunch of different function types here. This is one of those relative growth problems where you want to figure out if each thing is bottom heavy or top heavy. So going through, option 1 here, ln and x to the 99th, that's definitely bottom heavy. Ln is very slow. Even x would beat ln of x, so that's bottom heavy. Here, e to the x is way faster than ln of x, so that's top heavy. And for choice 3, x to the 99th and e to the x, this one's a little bit trickier, but hopefully you remember that exponential growth eventually outpaces polynomial growth every time. So this is also a bottom heavy function. Now the bottom heavy ones are the ones where you have an asymptote at y equals 0 and a limit at 0. So that means that choices 3 and 1 are the two options we want. So that would lead us to pick answer choice E. For number 11, we want to know which of these equations has y equals 1 as an asymptote. So taking a look at each of these, this is one of those process of elimination ones, I think. ln of x has no horizontal asymptote, has a vertical one, but not a horizontal one. Sine doesn't have any horizontal asymptote, it just keeps oscillating. This one, we have a rational function, so we can do the whole choose your champion thing. We've got x on the top and x on the bottom. That just reduces to 1, so that's looking like a pretty good answer choice at this point. Just for the heck of it, though, let's keep going and just make sure. So this one, this is going to reduce to x squared over x, or just x. If you plug infinity in there, you're going to get infinity, so no horizontal asymptote there. For this one, we've got essentially 1 over e to the x as x approaches infinity. So this is going to reduce to 0. This is bottom heavy. So that means that C is indeed the best option for this.